Got something exciting today. It's a Fender combo amp. It's the Stage 185. Now the first thing I notice, there's some black marks down here on this little thermistor, this little NTC. So some black marks on the circuit board underneath here. So I'm going to test this and maybe clean up the solder joints. See how that goes. There's also a popping sound this makes, which is notorious for these sort of amps anyway, but that might be the culprit, and we'll see if we can replace that. Second thing I've noticed is this cable here is the reverb send and return. See the terminals that are coming out of the PCB? So they're fairly solid and the wire is just soldered to them. Well, if you look at this, the ground wire on the red side, look at that terminal. So that needs to be fixed. It might mean resoldering the terminal, but I'm going to say that's probably broken. It's been pulled at. There is a strain relief on here, but just a little bit too tight. Looking over everything else, a lot of this preamp circuitry all looks good. The resistors aren't discolored. They all look fine. There's a couple of newer coloured resistors here. See those? They look like they may have been replacements from a previous service. There's one under here as well, under this shield. Okay. Most importantly, the usual suspects. Here we have the power section of things. Now these capacitors are likely the originals. So this is this is a red knob Fender, so you know we're talking 90s. So it's a good 20 to 30 years old. These caps, for the sake of offering replacements, I'm just going to, because they're probably starting to dry out. They're not bulging, which is great. Also looking in here, this huge 0.22 ohm resistor, and that's what it says. It says 0.22 ohm. So, you know, a quarter of an ohm. I'll have to measure that. And it says 10%. This thing's huge. It's about the size of my index finger. It's very dusty, and a lot of this ceramic coating is just failing. It's just... and I noticed that because I was looking here on these main wires that are coming off it, which look like they go to... they go to the extension, speaker extension. And so these wires here go to speaker extension. These wires here go to the internal speaker of the combo. But this resistor here, if you notice, there's some powdery stuff on there. So this resistor could just be falling apart, just disintegrating. Looking over this way, everything looks fine. These resistors usually have some brown marks underneath them on the circuit board. These ones here you can actually see on the circuit board. There's some brown markings there and some on this side. And these diodes as well. This part of the circuit board is probably providing the plus and minus 14 to 16 volts. I think with these Fenders, like a lot of the solid state Fenders, it's probably around the plus and minus 14.4, 14.6 volts. It varies depending on how much power is coming into the transformer, obviously. But these parts are going to be replaced regardless. If you look at these two diodes, you can see it looks like someone spilt coffee all over them. The reality is that they're probably just dying. They're probably overheating and dying. These two will be replaced. And generally, a lot of the times, that is a typical thing for these Fender amps and a lot of other solid-state Fender amps. We did the same thing with the Frontman 212R, and that fixed a lot of the problems. In fact, it fixed a lot of the negative 16 volts that was getting, according to the multimeter, and all of a sudden the amp started working again. These two resistors will be replaced. Oftentimes, these two resistors feed into the positive and negative of the transistors over here. Okay, now I haven't looked at a schematic diagram yet to determine if that's true or not, But the reality is, from experience, these two resistors can often fail, as do these two. For the sake of, you know, $1 or $2 each for these, we're talking $5 worth of parts, $6 here, maybe about $10 or $15 worth of parts for these. And this giant resistor here, I'm going to look at it and test it out and see if I can find one that is the right value for starters, and replace that as well. What I'm also going to do is see if I can source one of these relay looking input jacks, which is the input jack here that's been covered with gaffer tape. This one's fine, but might be worth replacing both of them as well, because they're plastic and they do fatigue and break. And you know, classic, what'll happen is I'll replace this one and then the customer will call me back a week later because this one broke. And the final thing, this volume pot here is completely snapped off, so I'm going to order a replacement one of those too. And order, some hidden resistors under here. I'm going to change these as well. Okay, so yes, I can measure them, and yes, I can probably find that they're within spec, but oftentimes what you'll find is that they are just so old, so worn out from heat and use, that for the sake of a few dollars, just replace them. Because the thing is, this circuit board has to come out. All these knobs have to be pulled out, unbolted, and taken out. You might as well, because you don't want the amp coming back a week later for the sake of $1, $2, $3, maybe $4 worth of parts, and having to do all this labor again to get it out. Parts finally arrived yesterday, so I'm going to work on it today. It's snowing up here in the mountains, not quite at the elevation that I'm at. I'm a little bit lower down, but a couple of 100 meters up the road, or a couple of kilometers up the road, a couple of 100 meters in elevation, it's snowing. So what a perfect day to work on this amplifier. So here are all my parts. I've got all my giant 10-watt resistors. Alright, so I've lifted the circuit board up. I've got it propped up on its side now so I can get access to the bottom. I'm just going to show you some of the things I've noticed that have been done to modify. So first thing that's noticeable is we've done the right thing. We've increased the solder here, the solder joints. Where I'm looking is right here. Now, first of all, what's probably happened is that the tracks have lifted off the board when these were replaced or modified. And when I say these, what I'm looking at is essentially, let's zoom out so we can get perspective here, is these joints here, okay, and these joints here. There's a little bit too much solder there. It's getting a bit close to that track, and as is that. Then again, you know, the PCB lines here, the circuit board lines, are pretty close there too. So this solder joint and this one here are going to that one diode, and then this solder joint and this one here are going to the other diode. And what's happened, they've been replaced before, obviously. I'm going to replace them, but I'm going to lift them up off the circuit board so there's air all around it and they're not flat against the circuit board. What I'm going to be really cautious with is that these solder marks here are not factory. It means this has been done before. And what that also means is it means that the solder tracks, or I should say, sorry, the circuit board tracks, the circuits themselves, it's lifted off the PCB. The other thing I noticed is this this pot here, this 50K pot, that's the treble. What they've done is they couldn't find one, obviously, that had the frame around it, like these typical Fender pots, and I think PV uses them as well. So they've gone and just grounded all of these, except look, this wire's not even connected. I'm going to keep the pot in there. I'm going to fix this up because I don't have one of these pots, and ordering them here in Australia is a nightmare. I have to actually replace this pot anyway because it's broken. This is the main volume pot. So what I'm going to do is I am going to replace it. I am likely going to replace it with something like this, but with a solid shaft, a solid D shaft. And I'm going to do a damn better job with these 4 posts here which is where this frame that goes around the pot is mounted. It also does make the pot a bit more secure, and that's one of the reasons they do it. Now finally, here is this 9-pin audio jack, and that's going to be a lot of fun replacing that as well. Alright, here we have the brand new caps installed, brand new filter caps, 3300 microfarad, 63 volt. So I'm going to assume that the output coming out of these is about 45, 46 volts DC. If they were close to 60, then I would be upgrading these to something else, like 100 volt. But most solid state Fenders, such as this one, you're looking at about the 42 to 45 volts DC coming out, plus and minus. So the next thing I'm going to do is remove these 10 watt 270 ohm resistors, and then the next step after that will be these diodes. Stay tuned. Alright, so I've taken this 10 watt 270 ohm resistor out. Look at the underside of it. Burnt. And then the other side, burnt. So what I did, because this is an area that's so delicate and compromised, and in fact, as soon as I touch the soldering iron on there and use my solder wick, or my solder sucker in this case, I should probably use solder wick, it's a little bit more delicate for this sort of job, I can see the tabs lifting, and on this side as well. So when I'm pushing through the new resistors, I'm going to be very gentle in the way that I'm doing that. Very, very gentle. Alright, so I got the new 270 ohm 10 watt resistors in. Notice I've got the pins still sticking out. I haven't cut them off yet. What I am going to do, just to reinforce these, because as I was putting these components in, the pads, the solder pads on here were lifting right off the circuit board. I was very, very gentle doing it. I'm sorry I didn't record it, but I needed both hands to make sure that these stay put. I have soldered them in place, but it's kind of like a tack weld right now. Okay, what I'm going to do now is I'm going to bend this pin over facing the direction of that circuit, this pin facing the direction of that circuit, this pin I'm going to bend over to here, and this one I'm going to bend over this way. And what I'm doing, actually before I bend this pin over, I've got to get these diodes out, so not just yet, and same as this one, but I'll do these two last after I do the diodes. Let me get this in focus again for you. I do apologize. I'm going to do these ones now because they're not really going anywhere, or I should say they're not connecting. There's no other circuit, no other solder joint here. So I'm just going to bend these over now and just reinforce it with solder. Alright, so this is what the repair looks like so far. I've put in those 270 ohm 10 watt resistors, replacing the 270 ohm 7 watt resistors. These are the two solder joints on this side, nice and tidy. I'll clean this gunk up off the end in a second. And this side, what I've done is, after I put the diodes in, I bent the pins over from the other side of the 270 ohm resistor over to this side where the diode meets. And that just reinforces that. And I've soldered both ends of the pins to this side just for that extra physical reinforcement. You can see this side, there's a little bit of corrosion. Or not, actually, it's not corrosion. You can see on this side where the masking on the PCB has been taken away. I'm just going to put a little bit of extra solder around here as well. You can see on this side there's a hole right there. I'm just going to tidy that up. Next thing we're going to do after that is head over to input number 1, input socket, unsolder all this, get rid of it, and replace it with the brand new one. Alrighty, so we have the new input socket in, soldered in, ready to go. So it looks like there's not enough solder on there, but there is, trust me. Alrighty, so let's have a look at the underside of the finished circuit board. We'll go from the left-hand side of the circuit board and work our way across. So filter caps have been replaced. The 7 watt resistors have been replaced with 10 watt resistors. Up the top here, I've replaced the input socket for channel 1 with a brand new socket. So no broken plastic piece. Unfortunately, you can't get a metal piece for these. They only come in plastic. So such is life. I've fixed up this little grounding circuit here for this replacement pot, so things are looking a little bit nicer, a little bit tidier, and the insulation is heat shrink around a length of wire. Let's go down the bottom here. I've replaced these 5 watt 0.22 ohm resistors going across here, and then this big 0.1 ohm 10 watt resistor going across here. So here we are on the top side of the chassis. I have put it in place, but I haven't done up all the bolts yet. What I'm going to do is plug this in and test it, make sure it's all working before I go ahead and tighten up the plethora of nuts. Alright, well, I think that's about it. Thanks for watching, guys. Don't forget to subscribe.